Hello everyone and welcome to Algebra 2. This is section 6.5, Properties of Logarithms. So at first, these properties might seem like a lot to learn, but if you know your properties of exponents, these actually make a lot of sense. Think about this. If you had a squared times a to the third, what would you do with those exponents? Would you add them or would you multiply them? Hopefully you recognize that since this is a times a, and then this is a times a, you're really looking at multiplying 5a's together, which can be represented by a to the fifth. So you add the exponents. And fortunately, you've already done the hard part of learning that when you multiply like bases, you add exponents, which is a weird concept that in order to multiply, you have to add. But now, since logarithms and exponents are inverses of each other, the same basic rule is going to apply. If you have log base b of m times n, that means the same thing as log base b of m plus log base b of n. And the same thing would work with subtraction. If you had a to the eighth over a squared, you would subtract those exponents. So you associate division with subtraction when it comes to exponents. So you're going to do the same thing with logs. If you're dividing two things, then you can separate it into two separate logs and subtract. And this last one is not a rule that we have in exponents, but I'm going to show it to you because it's very cool. Let's say you had log, I'll just do base 10, which means I don't have to write it, of x squared. This rule is saying that I can bring that 2 and put it down in front. So the question is, why does that work? Well, we're going to use the product property. If I have log of x squared, I could rewrite this as x times x. And then using the product property, that means I have log of x plus log of x, which then circles back to 2 log x. And so that's a unique property for logarithms that we actually use quite a bit. So if we were in school, which we're not, I would torture you by showing you that back when I was in school, I'm so old, that if I wanted to know the log base 5 of 3 over 7, I would have to get out a book filled with tables instead of just my calculator. And it's not going to have 3/7 in it. That's too specific. But it would have log base 5 of 3, and it would have log base 5 of 7. So what I could do is I could say, well, I can't do 3/7, but I can change this to log base 5 of 3 minus log base 5 of 7. And I could look both those up on my table. So log base 5 of 3 is 0.683. Log base 5 of 7 is 1.209. And that answer is negative 0.526. Similarly, if my table didn't go all the way up to 21, I could say, well, that's log base 5 of 3 times 7. So I could change that to log base 5 of 3 plus log base 5 of 7. And then I would have 0.683 plus 1.209, which would give me 1.892. Any ideas for C? So again, it might not go as high as 49 on my table, but I could change this to 7 squared, and then I could bring the 2 out front, and then I would have 2 times 1.209, which is 2.418. So this is archaic. We have calculators now that would do all these logarithms for us. We don't need to have these log tables in the back of books. However, I need you to, for at least 2 minutes of your life, appreciate your calculators and how far we've come, mostly because you guys are the next generation that will be producing people that come up with all kinds of technological advances. And that's why we're teaching you. All right, but we are going to use these rules to do something your calculator won't do, which is expand with variables. So pretty much it's a two-step process. Your first step is going to be to take care of any multiplication or addition. So I'm going to change this to natural log of 5x to the 7th minus natural log of y. And then I still have multiplication here, so I can change this to natural log of 5 plus natural log of x to the 7th minus natural log of y. And then finally, after you've done all the multiplication and subtraction, or multiplication and division that became addition and subtraction, then you can take care of your exponents. So your final step will be to move any exponents to the front. And this would be considered the expanded form of this natural log. So this does not really help you do very much now, but when you get to calculus, if you had to do calculus to this, you would cry. It's extremely difficult. But if you could break it down into 3 very simple problems, then the calculus will be easy. So these few years are preparing you for much harder level classes. So bear with us even if you don't understand why you're doing it yet. Okay, so the first step is to always take care of the multiplication or division. This one only has multiplication. It's easy to forget to write the base. This is log base 6, has to be rewritten every time. And then the second step is always to take care of your exponent, which you can bring out in front. And that is your simplified form. You should really stop this video and try the next 3 on your own. But of course, I am going to do them out. So first, this is natural log of 5 minus natural log of 12x, which is going to give me natural log of 5 minus, and I can break these down, but I have to remember the parentheses because both of them were on the bottom. Both of them are affected by this subtraction. So your final answer would be natural log of 5 minus natural log of 12 minus natural log of x. Letter D. When you have a square root, you probably want to do an extra step, and that is to change the square root to a fractional exponent. Oop, that's a y. That way you can move it out to the front. So don't try and move exponents first. First, take care of the addition and subtraction. So I was doing these out a little bit slowly. You can go a little bit faster if you're understanding what's going on, and that is do all the multiplication and division at the same time. So all of these things are being multiplied, they get added, and at the same step, this is being divided, so I change this to subtraction. And then my last step is to move any exponents to the front. Minus 1/2 log base 2 of y. And that's your final answer. Letter E. If you're still watching and haven't stopped, you should try and do it on your own. So again, I'm going to skip that first step. I think I can do it all at once. Unlike letter C, this one I'm going to try and do in one step. Well, not one step, 2 steps. So I do the log of y, and then I have 2 things. I think of this as 2 things in the denominator. So log base 7 of 3 minus log base 7 of x squared. So if you don't understand how I got that, let's go back up to this one. If you just do the subtraction first and then take care of this part, you have to remember to distribute the negative. But an easy way to think about it is everything on the top in the numerator is positive and everything in the denominator is being subtracted. A little bit of a shortcut if you understand what's happening. And your last step is always going to be moving the exponent to the front. Okay, now we're going to go backwards. Condense each of the following. So now I see the subtraction, and I'm going to write it as a single log with division. On this one, I have a number in front. So last time, remember that I took care of addition and subtraction first, and then I moved exponents to the front as my second step. So since I'm going backwards, I want to move exponents first. So the log base 6 doesn't have one, but I'm going to make this log of 2 squared minus log of 3. So move exponents first. And then write a single logarithm. Things that are being added are changed to multiplication, and things that are being subtracted are changed to division. And this is 4 times 6 is 24, divided by 3 is 8. Log of 8. On the next one, remember we're going backwards, so the first step should be to move anything in front to an exponent. And then the second step is to write a single log, and everything that's being multiplied can be changed to, everything that's added can be changed to multiplication, and anything that's being subtracted can be changed to division. 4 times 27 divided by 12 is 9. I will tell you the biggest mistake that I see in this section is not using a single log. People know when they see subtraction, they need to change it to division, but a surprising number of people will write log of x over log of 9. Okay, watch out. That is the biggest error that I see in this section. Otherwise, it goes really well for people. So first step, move all the exponents. So this is going to be log base 8 of x squared minus log base 8 of 5 minus log base 8 of y cubed. I change it to a single logarithm, and this is the only thing that's positive, so it's the only thing that goes on top. These are both negative, so they both become division. 5y cubed. If that doesn't really make sense why that works, you could think of it as log base 8 of x squared minus, and then put parentheses around this, log base 8 of 5 plus log base 8 of y cubed. Maybe that'll help you understand why this becomes log of x squared minus log base 8 of 5y cubed. These go together, and then it's log of x squared minus, and that's why the entire 5y cubed goes on the bottom, in case that helps you. So remember, when we're condensing, our first step is to move the exponents, which is the opposite of the first step in the other section. And actually, I'm going to do this one, well, I'll do it 2 different ways. I was going to say I'm going to do this one a little bit differently, because every once in a while a kid does this differently and they get confused. Log base 4 of y to the 5th. Since I have subtraction, I write it as a single logarithm of x to the 1/2 over y to the 5th. If you are the kind of person that likes to write things as a square root, this is also a great answer. So whichever one that you want. So sometimes kids will move the negative with the exponent. So they have log base 4 of x to the 1/2 plus log base 4 of y to the -5. They actually move the entire -5. That also works. Not as many people do it, but it does work. Watch what happens. So then I'm going to have a single logarithm. Now that they're being added, I'm going to change it to multiplication. But look, that means the same thing. You may remember that a negative exponent on top is the same thing as a positive exponent on the bottom. So it is the same answer, whichever way you do it. Next, we have a change of base formula. So again, this is something that's a little bit archaic, although there are plenty of calculators out there that still don't have a change of base. If you have the newer one, then your calculator will actually do this function and you don't need this at all. But just so that you know how to use it and so that you know how to interpret answers that are from older books and are still written in this form, I'll explain it to you. It's very simple. It just says that if you don't have a log base 3, which you don't on your basic function calculator, then you can change this to a log technically base 10 of 7, as long as you also make this a base 10 of 3, which of course we don't write the base 10. So you can just hit log 7 on your calculator divided by log 3 on your calculator, and that means the same thing as that. So let me go ahead and show it to you on your calculator. So if you want to do log base 3 of 7, you would go into math, and then you have to scroll all the way down past the numbers, past 0 until you get to A, and then hit enter. And look at that. It's exactly what you want. So you would do 3 and then 7, and you would hit enter and you get the answer. If you have a calculator that doesn't have that cool functionality, or if you're like me and you're just lazy about it, it's just as fast to do log of 7 divided by log of 3. And I get the exact same answer. So as long as you use both base 10, or actually both, you could have used natural log of 7 divided by natural log of 3, you're going to get the same answer. So personally, I don't bother to find this and then scroll all the way down until I get it and then fill in the different parts. I personally think it's just as easy to hit log 7 divided by log 3, but you can do what you want. So I'll do one more with you. If you have log base 6 of 15, I did log last time, so this time I'll do natural log. I can do natural log of 15 over natural log of 6, and I get 1.511. So just to show me that you understand, I'll let you do number 3 on your own, and you can type that into your calculator, make sure you know what you're doing, and I'll be checking for that when I check your notes. All right, word problem application. The loudness of a sound is measured in something called decibels. It's related to the intensity of a sound, which is measured in watts per square meter. The equation that you need for this is that loudness, L, decibels, is equal to 10 log of I over I sub 0, where I sub 0 is the intensity of 10 to the negative 12 watts per square meter. So it's corresponding roughly to the faintest sound that can be heard by humans. So this is a pretty cool chart here. It tells you different decibel levels. So the threshold of hearing is where they start at 0. And then you've got your soft whisper, quiet library, conversational speech, loud city traffic, now a subway train, a rock concert, and finally a jet airplane taking off is 130. So that gives you some concept of, if somebody says, oh, it's 50 decibels, you can say, well, that's just an average home, where 100 decibels would be really loud. So let's find the decibel level for a propeller aircraft. It has an intensity of 0.316. So its decibel level, which is L, its loudness, is going to be 10 log of I, its intensity is 0.316, divided by, and then I sub 0 is always going to be 10 to the negative 12. So you can just go ahead and type that into your calculator, and you should get 114.997 decibels. All right, but this next one's a little bit harder. 3 groups of people are in a room, and each group is having a conversation at an intensity of 1.4 times 10 to the negative 7th watt per square meter. What is the decibel level of one group? So let's do that first. So my formula, remember, is the decibels, loudness, is 10 log of I, the intensity, so 1.4 times 10 to the negative 7th, over I sub 0, which is 10 to the negative 12. So before you try and type this into your calculator, it might be easier for you to actually simplify it a little bit. If I bring this 10 to the negative 12 to the top, remember that a negative exponent in the denominator is the same as a positive exponent in the numerator. So this is really 1.4 times 10 to the positive 5. And if you type that into your calculator, you will get 51.461 decibels. So the question is, what do you think will be the decibel level once there's 3 conversations in the room? So this is 51 decibels for one conversation, which makes sense. It's an average home. There's a conversation going on. But if there's 3 conversations going on, will the decibel level be 3 times that? Will it be 150? Of course not. It's not going to be greater than a jet airplane going off. And that's the difference between intensity and decibel levels. So let's actually figure it out. 10 log of 3 times 1.4 times 10 to the negative 7th, all over 10 to the negative 12. So that's where you're going to put that 3, right in there. It's 3 times the intensity. So let's practice typing that into our calculator. So I do want 10 times log, and now I want a fraction. So I'm going to go to alpha F1 to make my fraction, hit enter, and then I want 3 times the quantity, 1.4 times 10 to the, now make sure you use this negative down here next to the enter and not the subtract button, minus 7, end parentheses, and then I can go down to my denominator here, 10 to the, again, use the negative button, 12, and now I want to get all the way over for my parentheses. And I get 56.2324929 decibels. I just want to make one point here, and that is sometimes I do these things for you and you're not really trying them on your own. If you get to a quiz and you say, can you help me type this in? The answer is going to be no. You need to try it here. It's why I'm showing it to you. So as you can see, we got 56.232 decibels, which is only 5 more decibels. So it's definitely not 3 times as many decibels just because there were 3 groups of people in the room. Okay, so that one was a little hard. Now number 3 is definitely the hardest. Last example for the day though. A certain sound has an intensity of I, so I'm not actually going to give it to you this time. By how many decibels does the sound increase when the intensity is tripled? So it's just like the one that we just did, but here we had actual numbers. So we could see that the decibel level increased by 5, even though the intensity was tripled. Now I want to know, in general, for any intensity I, how does it work? This is going to be a lot more challenging. Here's how we're going to do it. 10 log of I over I sub 0 versus L is equal to 10 log of 3I, so 3 times the intensity, over I sub 0. So if I use the properties of expanding, then I can change this to 10 times log of I minus log of I sub 0. And on this one, log of 10 times log of 3I. Actually, I think I can go ahead and skip this step, right? You guys know it. Plus log of I minus log of I sub 0, right? Both things are being multiplied, and then the one that's being divided is subtracted. And now we have 10 log I minus 10 log I sub 0 as my final answer for that one. And this one is 10 log 3 plus 10 log I minus 10 log I sub 0. Well, if you compare these two, they both have the 10 log I, and they both have minus 10 log I sub 0, which means this one is greater by 10 log 3. What is 10 log 3? Well, if you do 10 log 3 on your calculator, you will get 4.771 decibels. What is that? It's almost 5. Remember how we said this was about 5 decibels higher? It's actually 4.771 decibels higher. So no matter what sound, this is actually so cool, what sound you triple the intensity of, it doesn't matter if it's a jet airplane taking off. If you have 3 jet airplanes taking off at the same time, now it's just going to be 135 decibels. If you have conversational speech, but then 3 times as many people, it doesn't suddenly become 180 decibels. It just becomes 65 decibels. And we just figured that out by using our expanding and then comparing the two answers. All right, that is it for section 6.5. Have a great day.